Alright, so the first problem that we will be going over today is section 5.4, problem number 7. So please have out 5.4, problem number 7. This is the problem that was assigned on Tuesday. So let's read. Line L is tangent to the graph of y equals x minus x squared over 500 at the point Q, as shown in the figure below. So you see point Q is right here. Line L is right here, tangent to this graph, meaning both the line and the curve share point Q. You can also see that point Q goes through 0, 20. So A says find the x-coordinate of point Q. So how would we do that? Well, the x-coordinate of point Q, well, if you think about point Q, it is x, comma, y, but y is x minus x squared over 500. And so this is an x-y pair. Now, how would we solve for x? Well, there's two ways that we can think about using x. We can think about the fact that the line is tangent to the graph, meaning its slope of the tangent at x would be found by the derivative of y. And its slope is also found by taking the slope between 0, 20 and Q. So what we can do is we can actually set y prime equal to the slope of the secant line, which would be y2 minus y1 over x2 minus x1. So the derivative. So if you think about y, it's actually just x minus 1/500th x squared. So its derivative, y prime, is going to be 1 minus 2 times 1/500th, which would be 1/250th x. So that's the derivative. So we're going to set 1 minus 1 over 250 times x equal to the slope of the secant line, the slope of the line connecting the 2 points, 0, 20, and x, comma, x minus x squared over 500. So we're going to take x minus x squared over 500 minus 20 divided by x minus 0. So this is the slope of line L. So the slope of line L is the derivative at x, and the slope of line L is the slope of the secant line. So now we have an equation that we wish to solve for x. So if I want to do this, first thing I would do is I would drop the x minus 0, and I would multiply both sides by x. So if I do that, I end up with x minus 1/250th x squared equals, here the x just reduces, so x minus x squared over 500 minus 20. So now all that remains is some algebra. So I'm going to carry this equation up here. Now, the first thing I'm going to do is I'm going to combine my like terms. So I'm going to bring over the x on the right side by subtracting x. And when I do that, the x's just subtract out. But then I'm going to bring over the x squared over 500 by adding it. So on the left side, I have negative 1/250th x squared plus 1/500th x squared, and then equals negative 20. So now, if I do this, negative 1/250th plus 1 over 500. Well, 1 over 250 is really 2 over 500. So negative 2 over 500 x squared plus 1 over 500 x squared equals negative 20. So now if I do these, I get a negative 1 over 500 x squared equals negative 20. So now if I want to solve, I'm going to multiply both sides by negative 500. When I multiply by negative 500, I get 10,000 on the right side. So 10,000 equals x squared. So if I take the square root of 10,000, I end up with my value of x. So that means that x is 100. So that would be the x value of the point Q. So part B says write an equation for the line L. Well, what do I need for line L? I need a point and a slope. So I don't have the slope yet, but I can easily get it from the derivative. All right, so remember the point, the easiest point to use would be 0, 20. And then the slope, remember, is the value of the derivative, y prime, evaluated at x equals 100. So what is the derivative? So we wrote it up there, y prime equals 1 minus 1 over 250x. So 1 minus 1 over 250 times x, well, that would be 100. And so I get 1 minus 100 over 250. So these reduce, both divisible by 10. 10 over 25, they're both divisible by 5, so this would be 2/5. So 1 minus 2/5 is 3/5. So that means the slope of the tangent is 3/5. And if our point is 0, 20, our equation of line L, the tangent line, would be y minus 20 equals 3/5 times x minus 0. Or you could write y equals 3/5 x plus 20. So that would be our equation of line L. Either one would be acceptable. Now we will move on to part C. Part C says, suppose the graph of y equals x minus x squared over 500 shown in the figure, where x and y are measured in feet, represents a hill. There is a 50-foot tree growing vertically at the top of the hill. Does a spotlight at point P directed along line L shine on any part of the tree? So what you have to do is you have to think about the picture. Now I'm going to redraw the picture here. You have a tree on top, and you've got this point Q and point P over here that is directed along line L. So what we're really saying is that the light will shine everywhere above that line, but below will not, because that will be taken up by a shadow. So we are basically asking, is this line going to be less than 50 feet above the top of the curve? So how would we answer this question? Well, it's basically just a linear approximation question. So we need to know the point at which we are at the top of the curve. So how would we know that? Well, it's the vertex of this parabola, or in other words, it's when the derivative of that thing equals 0. So this occurs when y prime equals 0. So if we set y prime remember was 1 minus 1 over 250 x. So if we set this equal to 0 and we solve, we get 1 equals 1 over 250 times x. So if I multiply by 250, I get x equals 250. So x is 250. What is the y? Well, I can plug into my original equation. Y equals 250 minus 250 squared over 500. So if I do this, I get 250 squared equals 62,500 divided by 500 gives us 125, and so 250 minus 125 gives us 125. So the y value is 125, meaning the top of the hill is 125 feet high. If we have a 50-foot tall tree, the top of the tree, so I'll write this on the side, top of the tree is, well, 125 plus the 50 feet gives us 175 feet. So our question really is, does the light shine at a point lower than 175 feet? So how would we know that? Well, our equation of the line, y equals 3/5 x plus 20, if its y value is less than 175 feet, then that means the light would shine on part of the tree. So let's do a linear approximation when x is 250. So y equals 3/5 times 250 plus 20. So 3/5 times 250 gives us 150, plus 20 gives us 170 feet. So what does that mean? That means light would shine on the top 5 feet of the tree.